Okay, welcome to Maths with El Profe Lo, doing some elementary number theory and talking about some exam style questions on congruences. Okay, we solved this particular congruence previously, went through, did our setup. And if we want to look to the next one, we have prove that 7 divides 3 to the 2n plus 1 plus 2 to the n plus 2 for all natural numbers, right? And being in the set of natural numbers. Now, it should be pointed out that sometimes natural numbers are considered to start at 1. And that's going to be the natural number definition that we're using for this particular example. But many times, in particular with some Western and Eastern European countries, natural numbers are defined as starting at 0. This is not something that is clearly defined or in the math community. In the Americas, this tends to be the definition, but there are several European nations and that do define natural numbers as starting with 0. Okay, so how can we prove this? Well, anytime you're trying to prove divisibility, it helps to rewrite things in terms of ways that may get you, right, what you're looking for as a factor. So we're going to start playing around. And I see this to the 2n and this 2 to the n. And I'm going to come over here and make this notation. 3 to the 2n plus 1 is equal to 3 times 3 to the 2n, which is equal to 3 times 9 to the n, right? Which must be congruent to 3 times 2 to the n modulo 7. Why? Because 9 is congruent to 2 modulo 7. Okay? So why did I want to set this up? Because now I have a 2 to the n in this 3 to the 2n, and I also have this 2 to the n here, right? So 2 to the n plus 2, we know, is equal to 2 to the n times 4, which would be congruent to 2 to the n times 4 modulo 7. Okay. Can you see what's going to happen now? Well, if I have 3 times 2 to the n plus 2 to the n times 4, right, that's going to be congruent to 7 times 2 to the n modulo 7. And what do we know about this? We know that that would be congruent to 0, right? Because if I have 7 times a number modulo 7, right, then the remainder, when dividing by 7, is 0. So, therefore, 7 divides 3 to the 2n plus 1 plus 2 to the 2n plus 2, okay, which is what we were trying to demonstrate. Quod erat demonstrandum. Okay? Now, I will say that as a proof, one of the things that's missing is an important piece of information, and that would be that at the very beginning, to say, let n be a natural number, right? We're working with n, so we need to define n. So n is going to be a natural number. Then if we follow these steps, it necessarily follows that 7 does divide based on our congruences. Okay? So this was Maths with El Profe Lo, and as always, as you have questions, please reach out. We'll have a couple more videos dealing with exam style questions for congruences.